Hello everybody. Let's work today on another problem. It's related to logarithms. So you have to find the value of all x real numbers greater than 0 for which so this information is true. It's an logarithmic equation. Log base 4 of x and minus log x of 16 and equals 7 over 6 minus log base x of 8. So first of all, in the solution, let's go through the conditions. So the conditions are x cannot be equal to 0 or 1. Why not? Because if x is 0, that's not domain of the log x, and 1 is not the base. So those are the two conditions we have to consider before to start it. So domain of log x always greater than 0, and base also, the base cannot be equal to 1, otherwise a linear function, not exponential or logarithmic. So let's start this question. So let's rewrite it. So I'm going to write log base change to any base. So that formula I'm going to use. So log x over log 4 is equal to I can move that, or I can use still the negative sign, so we will transfer the terms later. So minus log 16 over log x equals 7 over 6, and minus log 8 over log x. So I change the base of all these logs to 10. So let's simplify a little more. So this is going to be log x over, if I will use log base 10 to power 2 minus, so I can rewrite this. So this is a log 16, so I can go with the log 16 as it is over x, and then I can say 7 over 6, and this side is also same. You can use log 8 over log x. This is also log x. So you can see there are two terms with the log and log x in the denominator. So first of all, what I will do in this section, the first one is log x over 2 log 2, and this is equal to, I can say this is 7 over 6, and then I can use this is going to be, this term is going to be moved on other side, will change to plus. So log 16 by log x, and minus log 8 over all log x. So that means I can rewrite 1 over 2 and 2 log x over log 2 equals 7 over 6, and plus, if I will combine these two terms, log x is my denominator, it's a log 16 minus log 8. So then the next part is 1 over 2, I can change log base to any base formula again. Log base 2 of x is equal to 7 over 6, plus in this situation I can go with the log 16 over 8, that's the quotient law in log over log x. That's again 2, so this is going to be 1 over 2 log base 2 of x is equal to 7 over 6, plus this is going to be log of 2 over log of x. So this is going to be opposite base, so I'm going to bring the log base 2 underneath now. So this is 1 over 2 log base 2 of x equal 7 over 6 plus 1 over log x over log of 2. So that means it's going to be 1 over 2 log base 2 of x is equal to 7 over 6 and plus 1 over log base 2 of x. I use the same formula. Stop for a second. Now we have to put a variable in. So let's suppose my t, let's say t is equal to log base 2 of x. Then let's see how my equation look like now. So that's going to be 1 over 2 into t is equal to 7 over 6 plus 1 over t. Let's simplify it. Let's say t is not equal to 0. So multiply everything by 60. So you will get here 3t squared equal So it's going to be 7t and plus 6, and bring them on one side. That would be 3t squared minus 7t, and minus 6 is equal to 0. So now I need sum equal -7 and product equal -18, and my two numbers are -9 and 2. So that means I will split the middle term. 3t squared minus 9t plus 2t minus 6 is 0. Group first two together, so 3t is out. Inside is t minus 3 plus 2 is out. T minus 3 equals 0. Simplify it, so t minus 3 is out. Inside 3t plus 2 is equal to 0. So this is only possible if t is equal to 3 or t is equal to -2/3. So also we have the value for t, so it's log base 2 of x is equal to 3. That means your x is going to be 2 to power 3, or x is going to be 8. That's the one answer you have. The second one is log base 2 of x is equal to -2/3. That means your x value is 2 raised to power -2 over, so 2 raised to power -2/3. That's my second answer. So these are the two solutions for this question. I hope you like the solution. Go through all this stuff to enhance your logarithmic skills. We are using a lot in here. We use the quadratic formula, we use the log laws, and a lot more information was in here. I hope this will help you, and enjoy your math. Thank you very much. Have a nice day. Bye.